Hello everyone, it's Robert from Darkflow, and we're going to be looking at how to make a game that may be very familiar to you. You might know it as Space Invaders. We're going to call our version Space Intruders. Well, let's get started. So first we need to add our images into the Darkflow project. So just click Add Image at the top and then select them from File. Give it an appropriate name. You'll notice I'm adding IMG to the end of some of the image names, and that's because we'll have objects for those images with similar names and I don't want a conflict. Right, for this one I'm going to be changing the frame height to 16, and that's the height of one frame of the animation. So your animated sprites are arranged with the frames vertically, and you need to specify what height you want for each frame. So just go through and add all your resources, import them all into the project. Almost done. I'll put a link in the description box to a zip with all these resources in. Okay, and now after we've imported all our images, we need to start adding objects for each of the elements in the game. So this one here, I'm going to make the player object, and I'm going to give it an appropriate image, which is our player image. And I'm just going to go through and I'm going to make all my objects now. You don't have to do them all in one go, but we'll just add all our objects into the project, and then we can get cracking. So yeah, I'm adding obj at the end of barrier here so that there isn't a conflict with the names of the image and the object resource. Okay, if you notice here in this shot image, it only showed a very small. I'll show you again because I'm just about to do another. It only showed you a very small square there, you see. So I'm going to go back into the image and I'm going to change the frame height, and now it should appear the right size. So it's time to plot the objects into my scene. So I'll set the background to black because it's in space, and I'm going to make it a bit wider and change the view, so the view should be the size of the scene in this instance, and then I start plotting my objects in. So if you notice at the bottom right of the screen, I've got snap objects to grid turned on, and what this does is it anchors the top right of the object to the top right of one grid square, and it makes it very handy for plotting things in neat rows and getting exact coordinates right. And I'll just add all my enemies in. Okay, now let's start working on the logic. First of all, I'll define an extra input because we need to make sure that we can shoot. So the space key is going to shoot. So I've gone into my platform inputs at the top and I've added the space key, and I'm going to define that as the space key for the PC and also for the browser. Okay, so now I should have another input in my events list. So right, on the create event for the player, I'm going to make a variable called canShoot, and this is going to be used in determining the shoot rate for the player, because if we didn't have this variable, if you held down the space key, he'd be constantly shooting and it wouldn't be a very good game. So we need to limit how frequently he can shoot. I'm also going to set an alarm of UFO to 120, which means after 120 frames, which is about 2 seconds, it's going to create the UFO moving across the top of the screen. So when the user clicks left, it's going to start moving left. All of this is fairly straightforward logic. And when he clicks right, he's going to start moving right. chosen a velocity of 4. And this is where we need to sort out shooting. When the user clicks space, if he is able to shoot, so that's where this variable comes into play. If shooting is permitted, then we disable shooting temporarily. We'll re-enable it with an alarm. But first we need to create the bullet. So shot. And we need to create it the X coordinate of the player, add a little offset to make it in the middle, so that's add 12, and then the Y position of the player, take away the height of, well, a little bit more than the height of the bullet, and that's to put it in the right place when it's created. And then we're going to set an alarm so that the user will be permitted to shoot again after about 1/6 of a second. So when the user releases all his keys, stop moving, otherwise he would just carry on moving off the screen after he lets go of the buttons. So in the step event, this means every frame it needs to check if an alarm is ringing. And if shot time is ringing, first of all we want to disable the alarm, because otherwise it will carry on executing the code in this block every frame, and we want it to only do it once. So we'll disable the alarm, and then we'll set can shoot back to 1, so the user's now able to shoot again. Okay, I'll also make a separate condition here, and it's going to be called if UFO, and that's where we do a similar thing. It's another timer. Make sure that your blocks are right. There we go. There's a new button that we've added in this release called check for problems. You'll see it at the top. So if you're not sure about your blocks, click that and it should tell you. So this is doing exactly the same with the UFO timer here, but it's also going to create a UFO. So if there isn't already a UFO on the screen, that's important because we don't want more than one, then it will create a UFO. And we'll put that at the top of the screen, and, well, 4 pixels from the top of the screen. Okay, so close off your blocks, and now I'm going to count the number of enemies. So if there aren't any enemies left, that's when the game is over. You've won the game. So we'll just get it to show a message saying you've won. Make sure that you use quotes in your strings, otherwise it'll think it's a variable and it'll return the value 0 if you haven't set that. So strings always must have quotes around them, and then it'll quit the game, and that's that done. Okay, that will do for now. We will now move on to our enemy. Now at the moment we've just got the one kind of enemy, so first of all let's animate it, and then we'll add a global variable here called global.enemySpeed, and that's going to determine how fast the enemies are going to move. Now we'll first of all start moving to the right with the speed, and this is going to change, which is why I'm using a variable to do it rather than a fixed 4 like I did for the player, because as the game progresses the baddies are going to get faster. So this is where I'm going to make the enemies different colours in effect. So all the enemies that have a Y value of 40, which is all the ones on that top row, I think it's the top row, I can't remember, but all of the ones on that row will have a different image, which is the other image I used for enemies. And similarly I'll do it for the row further down. So now the enemies will alternate in colour down the rows. You'll have a red row and a blue row. Okay, so let's just save what we've got so far. It's always good advice to keep saving as you go through your game. And now in the step event, so every frame we'll check that if the X is 316, and that means if it's gone to the right as far as it can, then it needs to reverse the speed of the enemy. So it'll set global.enemy speed to minus global.enemy speed. Okay, so it reverses the direction of it, and we'll set the velocity to the new velocity, and we'll apply to instances of enemy. So that means it will apply to all the baddies, not just the one that's at that position. And what I'm doing here is I'm making it jump back, because otherwise the next frame it would say if x is 316, then reverse the speed, so it would just carry on going in a straight line because it's changed it, and the next frame it instantly changes it back. So that's why I'm getting it to jump further back. And we need to do the same at the other side. So if the x is 4, so if it's right on the left, reverse the direction, set the new velocity, and then jump to the new position, which is going to be, and this time it's going to be, let's still apply to all of them, it'll be x plus enemy speed and y. And the reason we're using a plus, even though it's potentially negative, is because we've set the negative or positive stuff in the global.enemy speed, so we don't need to worry about that again. So now, with a 1 in 200 chance, the enemies are going to shoot at us. So we'll create an instance of enemy shot, and that'll just be at the x position plus an offset of I think it's 14, and then the y position, add the height of the enemy, which is 16. So every frame there's a 1 in 200 chance that an enemy will shoot at us, but that is for each individual enemy. So if there are 15 enemies on the screen, this is where we're going to start changing the speed. So at this point, at the instance where there are 15 enemies, if we've got the enemy speed of 1, then first of all we're going to snap to a 2x1 grid, and this is important for checking the x position, because at the top I said if x is this value, so we need to make sure that it's snapped to a 2x1 grid so that it will stay on the even numbers for the x position, because I've just increased the speed to 2, and that means every frame it will be moving 2 pixels at a time. So we'll do that, and the same for if it's going in the other direction. So we'll snap to grid again, set the speed this time to -2, and set the velocity and close off that block. Okay, now I'm going to count again. So if there are 5 this time, it's time to speed up again, and we'll do the same process, but this time we'll change the speed to 4, so it's doubling in speed again. So if the speed is 2, snap it to this time a 4x1 grid, set the new speed to 4, and set the velocity. And as I said before, the reason I'm selecting apply to instances of enemy, it means it won't just apply to the one running the code, it will apply to all of them. -4 this time, and set the new velocity. Okay, let's close off this block, and we're good to go. Right, now we need to sort out the logic for our UFO. So all our UFO is going to do is move across the top of the screen. So we'll give it a very low velocity, and then every frame, if it's greater than a certain X position, so if it has moved on such that its X position is larger than 352, we need to destroy the instance, because otherwise it will be sitting there in memory even though it's not on the screen, it's not visible, so it goes away. Now when a bullet hits something, first of all let's make our bullet move. So we will start it moving upwards with a velocity of 4. So every frame, if the shot has gone off the top of the screen, we need to delete it. Same principle as the UFO, we don't want them existing outside the visible region of the screen. And when it collides with an enemy, it also needs to disappear, but it needs to also delete the enemy, so that's why I've said other in the applies to. And that's when a shot hits the barrier. We need to get rid of the shot, but we don't get rid of the barrier. The barrier stays there. Okay, so we've done the same for the UFO here as we have done for these enemy ones. Okay. Right, now when a bullet collides with an enemy's bullet, we want it to delete the bullet like it does for an enemy. Right, and that's our logic done for the shot, but we've also got as a separate object the enemy shot, which is the bullets they fire at us. So this time we need to start it off moving downwards with a velocity of 4 again. And it also needs to remove itself when it gets below the bottom of the screen. So if the Y position is greater than the height of the screen, which is 240, then we need to delete the object. Right, so when the enemy collides with the player, this is when we can delete the player at this point, although it doesn't matter because we'll be showing the message, you lose. Okay? And we'll let them play again, so we'll restart the scene. When it collides with a barrier, it needs to delete the bullet, just as the player bullets die, and we'll give that a shot. And this is our game. You can see the UFO moving across the top, and the Space Invaders are of alternate colours. So this looks to be working very well. And I don't know if you've noticed, but they've sped up a little bit. See if we can get them to speed up again. So I just need to shoot enough of them. I can't remember how many we need to have before they speed up again. Ah, there we go. So now they're going much faster. And I've won. And just to show you that running on the browser, the same code will generate an identical game that will run in HTML5. So let's have a look at this. And it looks the same. And there we go. The game's going. And I operate it with exactly the same controls. And everything looks to be working. And I died. Okay, well, you get the idea. So that's how you make Space Intruders, and we hope to be producing a lot more of these tutorials soon, so keep watching and happy game making.